Okay, hello everyone. As we are continuing differentiation, class 12 exercise 5.3. Now we will be doing the differentiation of inverse trigonometric functions. So let's start with the question. Y is equal to sine inverse 2x upon 1 plus x square, and we have to differentiate this particular function. Now we will put x is equal to tan theta. Okay. And now what we'll get the answer is y is equal to sine inverse 2 tan theta whole upon 1 plus tan square theta. So now we will get y is equal to sine inverse sine 2 theta, which we will simply get y is equal to 2 theta. So what will be the value of theta? From here, if we can say, since x is equal to tan theta, so theta will be tan inverse x. So we can write y is equal to 2 times of tan inverse x. So on differentiating, we will get dy by dx equal to 2 upon 1 plus x square. Why? Because the differentiation of tan inverse x is equal to 1 upon 1 plus x square. Now the question arises, how I came on a conclusion that we have to put x is equal to tan theta and not any other trigonometric function. So first, in class 11 there were several formulas which we were told to learn or to understand. So one of those formulas is sine 2 theta. Now sine 2 theta, we all know it's 2 sine theta cos theta, but the other form of sine 2 theta is also 2 tan theta upon 1 plus tan square theta. Okay, so now let's understand, is it really true or not? Okay, so let's solve the RHS over here. So we can simply write 2 tan theta upon 1 plus tan square theta as 2 sin theta upon cos theta whole upon 1 plus sin square theta upon cos square theta. So this will become 2 sin theta upon cos theta whole upon cos square theta plus sin square theta whole upon cos square theta. So cos theta and square theta will cancel out. This cos theta will go up, and this cos square theta plus sin square theta will come over here. So what we will get is 2 sin theta cos theta upon cos square theta plus sin square theta. And we have studied that this is a trigonometric identity. So instead of cos square theta sin square theta, we can simply write 1. So hence our answer would be 2 sin theta cos theta, which is equal to sin 2 theta. So what we have to remember? We have to remember that sin 2 theta does not only means 2 sin theta cos theta, but it also means 2 tan theta upon 1 plus tan square theta. So these are the two formulas which are very important. Thank you. Okay, now let's continue with question number 10 and question number 11. So, as you can see, question number 10 says y is equal to tan inverse 3x minus x cube 1 minus 3x square. And so here, in place of x, again we will put x is equal to tan theta. So what we are going to get is y is equal to tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So y equal to tan inverse tan 3 theta. So y is equal to 3 theta. So since you put x equal to tan theta, so from here theta is equal to tan inverse x. So now y is equal to 3 tan inverse x. So dy by dx is equal to 3 upon 1 plus x square. So this is the answer for our question number 10. And why we put x equal to tan theta, because this is the formula for tan 3 theta. Again, this is a formula which was given in the class 11th maths notebook, and please, I would recommend you all to just go back to your class 11 books and check out the formulas for all the trigonometric and inverse trigonometric functions. And I will make a video regarding the formulas later, so that you can also check in my channel. Thank you. Okay. Now let's go to question number 11. In this question it is given y is equal to cos inverse 1 minus x square upon 1 plus x square. Now here we will again put x is equal to tan theta. So y is equal to cos inverse 1 minus tan square theta upon 1 plus tan square theta. So we will get y is equal to cos inverse cos 2 theta. So y is equal to 2 theta. So from here theta is equal to tan inverse x. So y is equal to 2 tan inverse x. So dy by dx will be 2 upon 1 plus x square. And this is the answer for question number 11. Now again, how come 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta? This is the formula. See, when you study the formula for cos 2 theta, we were told that there are three formulas for cos 2 theta. That is cos square theta minus sin square theta. And if we apply the trigonometric identity over here in this and next time in this, so you get two more formulas, that is 1 minus 2 sin square theta or 2 cos square theta minus 1. Now this is the fourth formula for cos theta, that is 1 minus tan square theta upon 1 plus tan square theta. Now if we want to prove it, we will simply prove it, because 1 minus sin square theta, we can simply write 1 minus sin square theta upon cos square theta. Now since there is nothing in denominator, that is there is 1, so the LCM of 1 and cos square theta will be cos square theta. So I can combine it and I can simply write cos square theta and cos square theta over here. Now whole upon 1 plus tan square theta can be written as sin square theta plus cos square theta upon cos square theta. Cos square theta cancel out. Sin square theta plus cos square theta is equal to 1 because it's a trigonometric identity, and hence what remains is cos square theta minus sin square theta, which is equal to cos 2 theta. So we have to understand the formula for cos 2 theta is this: cos square theta minus sin square theta. It's also this 1 minus 2 sin square theta. It's also this 2 cos square theta minus 1, and this as well. 1 minus tan square theta upon 1 plus tan square theta. I'll give you a few seconds to take the screenshot of the board. Okay, and then we'll move on to the next question. Thank you. Okay, now let's move on to question number 12. It says differentiate y equal to Sine inverse 1 minus x square upon 1 plus x square. Now, we have already did this part in the previous question. One of the previous question. So y put x equal to tan theta. What we will get y is equal to sine inverse 1 minus tan square theta upon 1 plus tan square theta. So which is equal to sine inverse cos 2 theta. Now here the question arises, this is sine inverse, this is cos, so how we will solve it? Okay, so let's understand this. We have again studied the concept of quadrant. So cos 2 theta can also be written as sine pi by 2 minus 2 theta, right? So sine pi by 2 minus 2 theta, that is sine 90 minus 2 theta, will always be equal to cos 2 theta. So in place of cos 2 theta, I can simply write sine inverse sine pi by 2 minus 2 theta. This will lie in the first quadrant. So we have studied in class 11. This is first quadrant, this is second quadrant, this is the third quadrant, this is the fourth quadrant, right? So this is the quadrant of 90 minus theta. So sine 90 minus theta will lie in this quadrant. So we will simply get y is equal to pi by 2 minus 2 theta. So on solving, on differentiating, we will get dy by dx equals to, or I should write first of all, y is equal to pi by 2 minus of 2. From here, theta will be tan inverse x. So I can simply write 2 tan inverse x, and now I can differentiate dy by dx equals to, the differentiation of constant is 0, so pi by 2 will become 0, and minus 2 upon 1 plus x square will be your answer for question number 12. Okay, please take the screenshot and then we'll go to question number 13. Okay, let's come to question number 13 now. So question number 13 says if y is equal to cos inverse 2x upon 1 plus x square. Again, put x is equal to tan theta. So it will be y is equal to cos inverse 2 tan theta upon 1 plus tan square theta. So now what we want to do is, we will write y is equal to cos inverse sine 2 theta. And again, the same scenario is over here. This is cos inverse, this is sine. So again, we can simply convert it. Cos inverse sine 2 theta can be written as cos pi by 2 minus 2 theta. So we got cos inverse cos. So simply we will get y is equal to pi by 2 minus 2 theta. In place of theta, we can again write pi by 2 minus 2 tan inverse x. So on differentiating dy by dx, we will get, again pi by 2 is constant, so differentiation is 0. We will get 2 minus 2 upon 1 plus x square. You can all take a screenshot. Thank you. Okay, now let's start with question number 14. It says y is equal to sine inverse 2x 1 minus x square. I can simply put x is equal to sine theta. See, when I see the question, such type of question, so I directly understand, okay, we have to put sine, we have to put cos, tan or cosine or whatever trigonometric function you have to put. But in order to understand or in order to see which trigonometric function should we put over here, first of all we have to practice a lot, because without practice and without remembering the formulas we cannot understand or we cannot recall which trigonometric function we will put over there. Okay, so for now let's put x is equal to sine theta in place of x. So it will become y is equal to sine inverse 2 sine theta under root 1 minus sine square theta. So y will be sine inverse 2 sine theta. As we all know, 1 minus sine square theta is cos square theta, so under root cos square theta. So y is equal to sine inverse 2 sine theta, cos square theta will become cos theta, and sine inverse sine 2 sine theta cos theta is always equal to sine 2 theta. So y will be equal to sine inverse sine, so we can simply get 2 theta, and from here we can say theta is equal to sine inverse, not tan inverse. So we have replaced tan question to make it tan नहीं आ रहा है, but okay, it's sine inverse x. Now अब क्या करेंगे हम? 2 sine inverse x. So on differentiating we'll get 2 upon under root 1 minus x square. Okay, now let's go to question number 15. Let's complete these two questions and then you can take the screenshot. So here this is a little different question. Okay, see, first of all it is set, then the function is in denominator, or I should say fraction, and it's 1 upon 2x square minus 1. Now we don't have any formula that says 1 upon something. Okay, so what we're going to do is we will take this sec inverse x to the other side, and it will become sec y is equal to 1 upon 2x square minus 1. And the sec is the reciprocal of cos, so we write 1 upon cos y is equal to 1 upon 2x square minus 1. So this implies cos y is equal to 2x square minus 1. You can say we cross multiplied, or you can simply say both numerators had 1 as the both denominators had 1 as the numerator, so we just reciprocally. So we can simply write y equals to cos inverse 2x square minus 1. So now the question is transformed from this to this. Now here we will put x is equal to cos theta. Why? Because we are seeing it is cos inverse 2 cos square theta minus 1, which is always equal to cos inverse cos 2 theta. So the value of y will be 2 theta. And from here we can say theta is equal to cos inverse x. So y is equal to cos inverse x. So dy by dx will be equal to 2 cos inverse x. So minus 2 upon under root 1 minus x square. This is the answer for question number 15. I will give you a few seconds to take the screenshot. And after completing the 15th question, the exercise 5.3 is completed. Now, in next video, we will be doing exercise 5.3, and before starting the next video, I am making a small video, a short video. Try to keep it short. I will try to keep it short about the formulas. We will discuss the formulas which will apply over here, and or in the next exercise on the integration. Okay. So